But your calculators do not have a button to simplify square roots.
Aww.
The calculators you guys had last year in geometry had the multi-views. You could press a button and it would take the square root of 12 and it would say it'd be 2 root 3. These won't do that. So what I need to do is show you guys real fast how you can simplify square roots in the calculator. There is a way to do this. If I'm looking at the square root of 24, we all know that you have to break that down into perfect squares. What's the largest perfect square that goes into 24? 6 isn't one, but 4 is. Root 24 can be rewritten as root 4 times root 6. What's the square root of 4?
2.
So the answer here would be 2 root 6. Now what I want you to do is take your calculator out.
Here we go.
And I want to go to the y equals part. And I want to do 24 divided by x squared. 24 divided by x squared.
Oh, you're actually writing x.
Alpha X.
Not alpha x, just it's the button next to the alpha.
Alpha.
It's right here.
Still press alpha.
Wait, what?
Where? It's next to alpha.
I just push alpha.
Got it.
Okay.
Can you push alpha?
Why is it all big?
I push alpha.
Because that's just how it is.
Don't press alpha.
Just press this
Oh,
button,
it's all
trust me.
small.
Okay?
Does it
Now,
matter?
I have no idea.
It's hard.
Second graph.
Now we have a table.
Right.
Second.
Now you're looking at a table. In that table, you will walk down the values. You will notice that, well, obviously, divided by 0, again, get an error. But what's happening in this table, well, some you can see it, 1, square root of 24. 2, square root of 6. 3, square root of 2.6667. 4, square root of 1.5. The largest whole number integer value you get before everything goes all decimals is what goes underneath the radical.
Neato.
The number out in front of it is what's the constant. So the square root of 24 is 2 root 6.
Wow.
Why?
That's how it simplifies it out.
The square root.
My calculator table starts at -2.
You can change your table set. Your table set, second window,
Second window.
and you can adjust where your table starts at. You can start it at 0 if you want,
You
-2 if
can
you
also
want,
just scroll up.
or just scroll up and
No,
down.
I can. Well, let me scroll
No, I
The
can.
next one is 3 root 10.
Let's try another one. The other one was square root of 90.
3 root 10.
Yeah.
So if I change the 24 to a
Your
90,
calculator, bro.
Wait, give me 1 second. What was the thing I'm trying to figure out?
90. And I go back to my table, notice the last number before everything goes decimal
3 is 10.
is 3 and 10. So that means that the square root of 90 is 3 root 10.
9 divided by.
Oh, your
I
table.
still start at -2.
And then do I press second?
Yeah, X equals 0.
16.
Press plus or.
Then what is it? 3? Yeah. Mine says 3 1. These are all.
Yeah, is anybody else not getting decimals in their table? Okay. If you're not getting decimals in your table like mine, what I want you to do is clear your memory. Second
Plus 7.
plus sign, 7, 1, 2. Second plus sign, 7, 2, 2. It's going to reset to all defaults. Over the course of time, if things getting dropped, batteries getting put back in, somebody might have had it last year during a stats program, they might have been using it for something differently, and they changed all the window settings and everything on
The
there.
other one was just second.
If you do second plus sign 712, second plus sign 722, it will reset everything for you.
Should I do this right now? Just for fun.
All right? It doesn't hurt to do
That's
that.
what I do.
Cool.
So what's going to happen here is that when we're solving these simple equations, oh, before we do that,
7.
I'll let you see what you can remember. So when we're getting into solving this stuff like this, you'll be able to leave your answers in what is called simplified radical form. There's no such thing as decimals. These are exact answers. Okay? So if I'm looking at a problem like this, what's up?
Oh, nothing, sorry.
Yeah.
If I have 2x squared plus 1 equals 17, I know that most of you guys have all solved multi-step equations that deal with square roots and stuff. The reminder thing that I'm going to throw at you today is the fact that you have to remember plus minuses when you go over an equal sign. That's what you'll forget. So if I solve this one out, first step, subtract 1, divide by 2. You cannot take a square root to undo an exponent prior to having anything else next to what has the exponent. Everything else has to be moved first. You're working backwards through the order of operations. Get rid of the exponent, you square root both sides. Since I did a square root on both sides of an equal sign, the rule that I have to remember is plus minus. And the square root of 8 is 2 root 2. There will be a few square roots that you will know off the top of your head real fast. Square root of 8, square root of 2, square root of 18, square root of 20, 24. Some of the very common ones that show up, you're going to know it right away.
Am I really?
You should. 27, 3 root 3, things like that. They're pretty common.
Yeah,
Okay.
I know that.
The other one that I wanted to show you here, I want to see if I get one with a fraction for you.
Oh,
Oh, great.
Yeah.
These are my favorite, you know that?
Like what?
1/3 times the quantity, x plus 5 quantity squared, equals 7.
Give me some time, okay? Like, I got you.
In this case here, I cannot take the square root of both sides because I've got a 1/3 out there. How do you move a 1/3?
Times divide. Divide.
Multiply by its reciprocal.
Yeah.
Multiply by 3. Very good. So multiply both sides by 3, and I get x plus 5 quantity squared is 21. Now what? Square root it. If I'm not mistaken, I don't believe that there's any perfect squares that go into 21 because the factors of 21 are 1, 3, 7, 21, so I don't have to worry about it. But what do I have to put out in front of it? Good. I have to put out in front of it a plus minus root 21. And lastly, what do I do?
How do you figure this out?
Subtract 5. Now here's what I want you guys to get in the habit of. This is one of the reasons why I showed this problem. Put the constant first.
Oh,
Bless you. Put it in front of the radical. It's more proper mathematical etiquette to have the whole numbers, the constant stuff, prior to a plus minus. Plus that way you don't accidentally put in there square root of 21 minus 5 and think that it's 16 and you get 4 and you're done. Okay? That would be bad. Does that make sense how I wrote that?
Yeah.
You guys probably did that with quadratic formula before.
probably not.
Hopefully you just kept the number out front. And that would be your solution. There's no decimal. That's an exact answer, and you're done. Okay. What was the other one I wanted to show you before I forget?
What's in my head? Sorry.
Man.
I saw that it was the.
Yeah, let's just stop here. Okay. So what I want you to work on tonight is some. I just want to do a few of these solving equations with this.
Four.
Let me pick a couple of them.
Like 20, a couple, like 2. I wonder if this smartboard catches everything we're saying.
Let's see here.
Right now, I probably can't see it.
Let's do. Let's do 54 to 65.
Wait, what?
So like this smart comment, it'll be later on.
Page what?
54 to 65, so it's 267.
And 67. Alright. What? Chapter 5.3?
Yeah, I'll write it down. Let's get this on here.
Yeah.
I'd like you to do, this is 5.3, page, what did I say, it was 267?
No. Just send me a picture when we get home. Alicia. Just send me pictures when you get home. Yeah.
All right, 64 to 65 and 68. I forgot about that one.
Oh,
What's wrong with 68? It's easy.
I mean, you could go that easy. Simply
Yeah. Simplify it. All right, we'll build off this tomorrow. We'll get into the imaginary numbers tomorrow. That's when things get fun.
I love imaginary numbers. Technically, numbers themselves. Think about it. Numbers don't exist.
Oh, I know that. You were asking something earlier because I wanted to show a bunch of that stuff before I got bogged down.
I don't know if you'll still be able to remember it.
So how do I do the square root thing on this calculator?
Same way. Oh, that one? Oh, you do the same thing with your table function.